Hello students, welcome to your first video lesson from section 5.2.1. Today we are going to start doing calculus. It's an introduction to what we call the limit of a function at a certain point, and that is essentially the most basic version of calculus, okay, analyzing functions and their graphs. So we're going to be looking at problems 41, 42, 43 today, which are in your textbooks on what page? I should have done this earlier. Page 240 in your textbooks. The first problem asks us to sketch a graph. I've given the function here. This is the type of function that we've been graphing throughout this chapter, sort of reviewing how this works. It is a reciprocal function, sort of, that's been shifted up. It's definitely a rational function where we have those two asymptotes, horizontal asymptote, vertical asymptote. So I'm going to start by graphing those. Hopefully from that equation at this point we can identify those asymptotes. My horizontal asymptote comes from this vertical shift of up 3 there, plus 3. So I have a horizontal asymptote here at y equals 3. Okay, there's a horizontal asymptote. I have a vertical asymptote at x equals 2 because the bottom here shows me that it's been shifted to the right by 2. So I'm going to go ahead and put that asymptote in here as well. Okay, so I have those two asymptotes, vertical and horizontal. And then the top of the function, the top of the fraction tells me some x and y coordinate points that I can find. In this case, I'm just going to go 1 and 1 from the new intersection point of those asymptotes, and then -1 and -1 as well down here, and then up along that asymptote there, down along this asymptote here, and the same going back this way. All right, so that's the first thing that they want us to do. Sketch a graph of this function. Okay, so I have that function graphed there for you. And then the problem says, place a bold dot on the point of the graph that corresponds to x equals 5. Okay, so I might do maybe a blue dot. And I'm going to try to make my dot a little bit bigger. At x equals 5. So if I go over here, 1, 2, 3, 4, 5, right there. Okay, that's where we're talking about, x equals 5. What it says is Bennybug starts at that spot right there. Okay, so if I go ahead and I make a little picture for you. We put a little bug, give him a couple of legs here. Okay, a couple antenna. So he starts right there at that blue dot. And he crawls along the curve, moving to the right. Whoops, so I put him backwards. I apologize for that. He's going this way, moving to the right. So yeah, he's going to walk backwards, I guess. If he keeps going in this direction, what y value does he think he's getting closer to? What y value does Benny think he's getting closer to? Okay, as he keeps going further and further to the right, what y value does he think he's going to get to? Essentially is what we're asking, okay? What does he think he's going to get to? And the answer to that is 3, right? The y value that he thinks he's going to get to if he crawls along this curve this way forever, he's pretty sure he's going to get to 3. Is he going to get to 3? No, he's not. But that's not really what the question is asking. The question's asking, where does he think he's going to get to? Okay, he thinks he's going to get to 3. So the answer to number 41, he thinks he's going to get to a y value of 3. Okay, notice this is also our horizontal asymptote. We'll talk a lot more about these kinds of things in our next video, okay? So that's all that number 41 is asking about, okay? Just wanted us to sketch the graph, remind ourselves what this looks like, and then we'll come back to this graph in number 43. So don't lose that graph, but I'm going to go on to the next slide here and look down at number 42. We have a new graph, which is actually a piecewise function. It's got a little jump. Okay, so we see this function, this graph generally. Theirs is a little bit flatter than mine, but it's the same general idea. So what the problem says here, letter A says Benny bug, the same bug that we had before, starts at the point x equals 6. Okay, so if I went to x equals 6, 1, 2, 3, 4, 5, 6, right about there. Okay, if I put my bug on x equals 6, give him a couple antennas, a little eyeball. Okay, there's my bug, and he's going to walk now like he's going uphill, moving to the left. Okay, so he's going uphill, he's going this way. The question is, what y value, how high does Benny think he's going to get as x gets closer to 3? So as Benny is walking back up the hill from 6 to 3, so 3 is, right in this area, x equals 3 here. How high does he think he's going to get? What y value does Benny think he's going to get to when he arrives at x equals 3? And the answer to that is he thinks he's going to be here, right? He thinks he's going to be right here at that open circle, which is a y value, again, of 3. So Benny thinks that when he gets to x equals 3, his y value is going to be 3. Is the y value going to be 3? No, it's not, because of that open circle that actually jumps down to here. But that's not really what we're asking. Again, we're asking, where does the bug think he's going to get to when x equals 3? And if he starts at 6 and comes from this direction, he thinks he's going to get to y equals 3. Okay? Now, the problem also asks if Benny has a sister, and she starts at x equals -3. So she starts 1, 2, 3. She starts basically like way back here. Okay, starts back here, give her a couple of legs, some antenna, a little eyeball. Okay, so there's my bug. She's starting back here, and she's also going to walk towards this point. Okay, so she's going to walk to the right, sort of going up the hill there. As she approaches an x value of 3, again, we're talking right here. As she approaches this x value, what y value does she think she's going to hit? Well, she thinks that she's going to get right about to this black dot right there. So that would be a y value of 1. Okay, so she thinks she's going to get to a y value of 1. Y value equal to 1. Okay, now is she actually going to get to a y value of 1? Yes, she is. In this case, she is actually going to get to the y value she thinks she will. She's going to get to y equals 1 when x equals 3. Okay? So when we talk about what y value are we approaching as we get close to a certain x value, is this thing called a limit. Okay, the limit of a function. I think that's it for 42. The limit of a function, okay, which has this notation here. Okay, this is our notation for a limit. There's one thing I haven't filled in yet, but I will here in just a second. Essentially, what a limit is saying is for a certain function, f of x, I've given us the one from number 41 here as well. For a certain function, what y value or what height of that function do we think we're going to get to as x approaches a certain value? Okay. Now, a one-sided limit, which we're going to talk about first, a one-sided limit is the value, I should say the y value we approach as x approaches a certain value from one side, okay? And the way that we denote the one side is we denote either the positive side or the negative side, okay? Also known as like from above or from below. And I'll show you what that means here in just a second. But let's say that I want to go back to my function for number 41. Okay, if I want to go back to this function, and I want to talk about what's happening to the function as the x value is getting close to 2. As the x value is getting close to 2. So x equals 2, hopefully we remember, is this vertical asymptote right here. This is x equals 2. So as my function is approaching that x value from both sides, what is happening to my function, right? What's happening to the y value of my function? Well, it sort of depends on which side we're approaching from, right? If I were to take Benny Bug here and not have him go this way, okay, but instead I were to have him go this way, right, to the left in this case. If he goes up this mountain here, approaching x equals 3, when he gets to x equals 3, he's pretty sure he's going to be like at the top of Mount Everest, right? As high as he can possibly be. So what we say then, what we write is this. If I go back to my limit stuff here, the limit as x approaches 2. Now Benny Bug in this case is approaching 2 from the positive side, okay? Because he's above x equals 2 right now, right? From above. And he's sort of going backwards in the x direction, approaching 2. So my limit notation then says the limit as x approaches 2 from the positive, okay? From above, to from above, okay? So it's not that I'm going positive right now. I'm coming from the positive, approaching 2. So x is approaching 2 from above of this particular function f of x. The limit as x approaches 2 from above of this function is equal to what y value does he think he's going to get to? That's the question. What y value does Benny Bug think he's going to get to if he goes to x equals 2? Well, he doesn't think there's any limit on his y value, right? He's going to go up forever and ever and ever. So he's actually going to consider his limit to be infinity. Okay, so the limit as x approaches 2 from that positive side working back towards 2 is positive infinity, okay? If I think about approaching 2 from the negative side, okay, so again, this is my notation, the limit, LIM, limit, as x approaches 2 from the negative, from below, working up to 2 now. If I go here to my function, right, and if I were to, you know, put Benny's sister over here and have her walk this way, as she approaches x equals 2, what y value does she think she's going to hit? Well, she doesn't think there's any limit to hers either, but she's going down off the cliff, right? Bottom of the Atlantic Ocean to the core of the Earth. So her limit from the bottom side or from the negative side of this function, we would say is negative infinity, okay? That limit is negative infinity because she's just going to keep going as she approaches x equals 2. She's going to go down forever, and there's not going to be a limit on how far down she can go, okay? So it's negative infinity. So one-sided limits at vertical asymptotes, you guys, are going to be positive infinity or negative infinity. Those are going to be our choices because that's what happens at those asymptotes, okay? If I were to do a limit, let's say, of this other function, let's say I was looking at this function, okay, and let me just type out something here. If I type out limit, for this particular function, the limit as x approaches, let's say the limit as x approaches 3, but we're going to approach it from the positive side. Okay, the limit as x approaches 3 from the positive. So that's our black bug right here, this guy. He's walking back from the positive, from above, back towards x equals 3. What value does he think his function is going to take, f of x? Okay, the limit of f of x as x approaches 3 from the positive side is going to equal, I believe 3, right? We decided he thought he was going to get to y equals 3. So this would be a one-sided limit for this particular function as we approach 3 from the positive side. And I can do the same thing. The limit of f of x as x approaches 3 from the negative side, right? 3 from the negative side, so coming from this way, from the negative, approaching 3. That's the purple bug here. Coming up, what y value do they think they're going to hit when x equals 3? They believe they're going to be at y equals 1. Okay, so this would be a one-sided limit statement for this function, x approaching 3 from the negative side. Okay? So whenever we talk about limits, all we're asking is, what y value do we think we're going to get to? Coming from this side or coming from this side? Now, I want you to recognize that these two are not the same. Okay? These two are not the same thing. So when we have one-sided limits at the same x value that do not agree, okay, we don't have what we call a two-sided limit. Okay, but let's talk just briefly about a two-sided limit. A two-sided limit is the y value we approach as x approaches a certain value from both sides. Okay? If the two sides don't agree, we say, like Mean Girls, hopefully we're familiar, what do we say? The limit does not exist. The limit does not exist, even though the girl with the snaggletooth needed an eyebrow wax or whatever. Okay, so we say the limit does not exist. Exist. And then our notation for that, by the way, is just DNE, does not exist. Okay, does not exist. So a two-sided limit is very much the same as a one-sided limit, but your two sides have to agree in order for that to exist, okay? If it does exist, you can write your limit statements like this. Limit of some function, I'll go g of x just to spice things up a little bit. Okay, so we can go limit of g of x as x approaches, let's say 0. And then we don't put a positive or negative. Okay, so here on my 0, I'm not going to put a plus or a minus because I'm not talking about just from the positive or just from the negative. I'm talking about both sides. So a two-sided limit, we do not use the positive and negative notation on the number. Okay, it's putting both of them together and just talking about that number in itself. Okay, so the limit of some certain function as x approaches 0. Now, if it's a function where everything's pretty much normal, then it's just going to be whatever the y value is at that x value. Okay, whatever the y value is at that x value. If it's a piecewise function, we'll have to talk a little bit more about that later because it's going to depend. Do the two sides match up? If they do, then great, we can have a two-sided limit. If not, then we would say DNE. Okay, but it might, let's say the limit as x approaches 0 of g of x might be 5. Okay? Both sides might think we're getting to y equals 5. Okay? So two-sided limits do not have the positive or negative. Both sides have to agree for that to exist. One-sided limits we can always write. We just have to denote from the positive, from the negative. Okay? What I would like to see for 43 would be sort of this stuff here, and also this stuff. Okay, this is 43C. 43C would be this guy and that guy. All right, so beyond that, you just have a couple of homework problems to work on. If you have any questions about limits, how we find them, what they're all about, one-sided or two-sided, please reach out to me at some point. Otherwise, that's all I have for you, and we'll talk to you soon.